All right, let's move into our double angles. Now this section you might see also has product to sum in it. I don't teach the product to sum or sum to product. If you'd like to know more about it, look into your textbook. I've never found a need for it. I know there are some uses, but you can pretty much just look it up if you might be in one of those weird cases where you need it. Okay, let's get into double angles. Now I told you before, like really the big game, why we want to know our sum formulas, like sine of an angle plus an angle and cosine of an angle plus an angle. It's because these formulas are the backbone, the basis of all of our multiple angle identities. How we deal with when we have 2 times an x, or half an x, or half an angle, or twice an angle. And it may seem weird, but there's need for it, and we're going to want to know how to do it, and especially if you're going the calculus path. Okay. And the reason this is important is we're going to want to find something like this. What's sine of, and I'm going to use a different angle. What's sine of 2 times theta? 2 times theta. Different angle. And I want to get this basically just as a term. I want all the terms. I don't want a 2 theta in there. I just want everything to be thetas. Now if you look up above, something plus something. What does it mean to have 2 of something? Isn't it true that 2 theta is just theta plus theta? It is. It's just theta plus theta. But we have a sum formula. So it was telling us is instead of just plugging in alphas and betas, everywhere you see an alpha or a beta, plug in theta. So sine theta, cosine theta. Plus, so it still goes sine, cosine, cosine, sine. But they're all thetas. But look here. Multiplication and addition are commutative. So we can turn this thing around and really, it's 2 of them. It's one of those thingies plus another one of those thingies gives us 2 of those thingies. So we find out that sine's double angle is equal to 2 times sine of theta, cosine theta. And there's your double angle formula. Know that formula. That's a pretty, it's not a bad one. It's just a lot simpler because again, cosine's a dick. Oh, yeah, cosine is more of the pain in the ass. So let's see it. All right. So let's move over. And let's look at this. What about cosine of alpha plus beta? We're going to play that same game. Oh, well, what's cosine of 2 times theta? Let's find the double angle, twice the angle. I'm like, okay, well, that's cosine of theta plus theta. So we'll just replace all of our alphas and betas with theta. So you get cosine theta times cosine theta minus sine theta times sine theta, which is equal to cosine squared of theta minus sine squared of theta. And that, my friends, is cosine's double angle. Or should I say 1 of 3. But there's only 1. It's just the fact that we can change cosine squareds into sine squareds. And we can change sine squareds into cosine squareds. So we can do all kinds of other manipulations with them. But there will be times when you're going to want to know all 3 will be important to know later, just for different scenarios and situations. So there is our first cosine double angle. Again, cosine can't behave nicely, can it? It's got to be a little bit of a jerk about everything. So before we fill in the other 2, let's go down to the bottom and let's look. Let's mess with it. Go cosine squared of theta. And now instead of writing in minus sine squared, I'm going to replace sine squared with 1 minus cosine squared. So this is cosine squared of theta. This should feel familiar to you if you've been keeping up with the course. We've done identities like this. And there's our next. We get 2 cosine squareds of theta minus 1. And by the same logic, we could also say that this is, instead of writing in cosine squared, we could put in 1 minus sine squared of theta. and then minus our sine squared. I'm just replacing the cosine squared this time. So this becomes 1 minus 2 sine squareds of theta. This is also equal to cosine's double angle. Wow, that's not right. Not cosine sine squared. These are all cosine double angles. But if you notice, like the game, you're like, well, what the heck does this mean? We have twice an angle, but all of these just have the angle. So it's like it almost reduces things down for us. And in other ways, this is going to become a giant concept of calculus, something we're going to have to deal with on a regular basis if you're heading that way. If you're just going to physics, you'll need it, but maybe not quite this level. So here's what we have so far. We have our sine's double angle, we have our cosine's double angle. Now, you know what? Tangent's double angle? Sure. I'm a trig teacher, so I mean, I assume I should probably teach it to you. Shoot, I don't have it memorized, though. I don't have it memorized. What could I do? Maybe we could do this. I think I remember from last time, though. I think I remember that tangent of alpha plus beta, if I remember correctly, since we just did this, I had to write this down for you. It would have been 1 minus tangent of alpha, tangent of beta. Shit. All right, so let's play that same game. Let's go find tangent of 2 theta, which is equal to tangent of theta plus theta. So you get tangent of theta plus tangent of theta all over 1 minus tangent of theta times tangent of theta. Oh, neat. I'll be damned. Look at that. It's going to become 2 times tangent of theta, right? Because up here we have one thingy plus another thingy. Down below we get 1 minus tangent squared of theta, because now we're multiplying. So this is telling us that tangent's double angle is 2 times tangent over 1 minus tangent squared of theta. That's not secant squared down there either. Looks similar, but it's not. Signs are off. So there's tangent's double angle. I personally, I don't ever really try and set you up for it at all. But there it is. Can't say I never showed you. You know what I mean? So there's the 3 of them, and if I was to ever give you something like this, secant of 2 theta, you're like, whatever, dude. I don't deal with that shit. I'm not filling my brain up with a bunch of formulas that I don't need to, because you know how to flip them over. So there's our tangent, sine, and cosine's double angle. We're going to also learn the reduction formula and the half angles. There's 3 different pieces through this. So this is the first one. Next, we'll go through our halves and our reductions. Let's see.